All right, so I'm gonna call this review number 1. We're gonna have tons of reviews, so call it review number 1. And back to number 1 here. I'm multiplying this quantity by 3/2, right? I have to get rid of that fraction. A, I don't really do good with fractions, right? B, I don't want to distribute and work. It'd be really messy. So in order to get rid of, think of it as a coefficient, right? What's the easiest way to get rid of a fractional coefficient? Yeah, multiply it by the reciprocal. You're the only one that remembered that. So I'm going to multiply both sides by the reciprocal 2/3. Okay, this and this cancel. That leaves me with my x minus 6. And what's 12 times 2/3? Or what's 2/3 of 12? Break 12 up into thirds.
4.
4, right? Wait, hang on. I got 2 of them though, right? 2 4s, which is 8. Good. Good job. All right, and then I got to get rid of the 6 or undo the minus 6. So I'm going to add 6 to both sides, right? So I get x equal 14. And that's it. Number 2A. Remember when we did absolute values? We made two. You have to have 2 problems. Absolute values, 2 problems. That was the key. Okay, so we're going to take what's inside and make 2 problems out of it, right? Oh, let's talk a little bit about the inequality. When I have a greater than or equal to, this is going to be an or problem. Okay? If I have a less than, it's going to be an and problem. Okay, or problems, if you remember when we go to graph them, it's going to be a parenthesis or bracket and then shade towards negative infinity, parenthesis or bracket, and shade towards positive infinity. Our ands are going to shade in between, right? So I have my parenthesis or bracket, and we shade in between. I keep looking at my computer screen to keep track, but it's out. Okay. So we're splitting up the problem. I take what's inside, my x minus 7. I like to start with my negative number, so I'm going to make that negative 13. But remember, I'm going from a positive to a negative with an inequality, so I have to flip it. We already determined it's an or problem. And then the other one is x minus 7, and I keep everything the same. And then I've got 2 problems to solve. So I'm going to add 7 to both sides. I get x less than or equal to negative 13 plus 7, negative 6. Do the same thing to the other side. Add 7, add 7. X is going to equal, greater than or equal to 20. That is my inequality solution. X is less than or equal to negative 6, or x is greater than or equal to 20. Graph it. I like to, well, you should put the smaller number here and the larger number here. See, it's an OR problem, so they're going to go out to their respective infinities. And they both have an equal sign. Yep, brackets. So our intervals, well, I got my negative infinity, which always gets parentheses, comma, comes here to my negative 6, bracket, ors get that union. I like to put it in the space, but it's up to you. Bracket, 20, and then positive infinity. Okay, don't do 3. You guys can do 2b. Okay, 4 is by square roots. We just did that, right? We just got tested on that. Huh? No, we did not do that this year.
Like you can cross it out.
Yeah, just cross it out. 4 was by taking the square roots of both sides. We just did that, right? You guys should be able to do this. Minus 60 from both sides. I get 2x squared equals negative 50. Negative 50. Divide by the coefficient 2. I'm going to bring it up here. So I get x squared is equal to negative 50 divided by 2. Negative 25. Take the square root of both sides. Cancels out that power of 2. X is going to equal plus or minus the square root of negative 25. And now you guys know how to take the square root of negative numbers, right? This is going to equal plus or minus the square root of 25 times the square root of negative 1. Square root of 25, 5, square root of negative 1, I. So x equals plus or minus 5i. Transformations, I let my other class do it by themselves, and they had kind of a lot of trouble. Let's go over the generalizations of the process of the transformations. If it's inside the transformations, and this goes with any function, right? Radicals, what do we do? Absolute value functions, quadratic functions. This is the same for all of them. Transformations. Okay? If it's with the with or under or in, with, under, within, the mathematical symbol, whether it's parentheses or radicals or you go left or right, opposite the sign. Okay. If it's outside the mathematical symbol,
No, assignments and
you go up or down. It's just coming back to you. And you follow the sign. Okay. That's basic. There were three more, but those were the basic ones. So here I have the f of x equals square root of x. Now we're supposed to make a brand new function called the g of x, and we're going to shift it left 4 units. So it's going to be under our math symbol, right? So here's my math symbol. I have my x, and I'm going to shift it 4. Let's see, it's got to go to the left, but it's opposite, right? Opposite the sign. So if I want it to go left, I don't want a minus, I want a plus. So that's left 4 units. And then it wants to go, tells me to go down 9 units. So here's my 9 units outside the math symbol. So I follow the sign, so down is negative. So there's my g of x. Now we got a whole, 3 other transformations, right? We got the slope, the flipping, the reflect, the wider and the narrower, right? Skinnier, stretch and compress. Number 6 is our systems of equations problems. Okay? It says the school that Jenna goes to.
Is that the answer?
Yep, that's my answer. There's my g of x. Whoops. There. Oh, I suppose I should put it here. Huh? Square root of x plus 4 minus 9. All right, back to the systems. The school that Jenna goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child tickets for $38. So there's one equation. And then the school took in $52 on the second day. So here's my second equation, right? Selling 3 senior citizens and 2 child. There's my second equation. Well, what kind of tickets do we have?
Expensive ones.
Expensive ones. Good, good. Okay, so we have senior citizens. We should say number of senior citizen tickets, right? And then the child tickets. Number of child tickets. And then let's write our equations up, huh? Let's see, we've got 3 senior citizens, so 3x. No, that's not the number, it's the price, isn't it? My bad. They tell us the number. Bless you.
Thank you.
That's the price. Oh, man. See, now I'm down to a B on my test. Much better. Because they give us the number. 3 senior citizens and 1 child, which is Y, equals 38. And then my second equation, 3 senior citizens and 2 child equals 52. And that's it. We don't have to solve it. Takes too long. Remember that one? Okay, this is 2.1. This was domain and range. Very easy when you have a graph. Is it a function? Just do the vertical line test, right? Crosses only at one point. Yes, it's a function. Passes vertical line test. Domain are my x values, right? Use the x-axis. Bring these up to the x-axis or down. So it starts at -8 and it goes to 3. Includes those points. And then do the same with the y. So it starts here at -4. And goes up here to 5. That's it. Eight is mathematical model. Okay. 8 is mathematical. What are you going to do with this? What's the easiest way to do mathematical modeling? Calculators. You're going to put it in your y equals, right? Let's see, we got use the negative key, -16, got to use the x key, squared minus 140x.
Wait, is it minus or plus?
Oh, I'm sorry, plus. I put a plus. Plus 3. And then graph it. Now, it's not, the only thing we have to do here is fill out the chart and find the slope, the average rate of change. So I don't even need to fit it in my screen or anything. So I'm going to go to my chart. Second graph brings up my table. Let's see, when x is 3, what's my y? 279. When x is 4, 307. X is 5. Okay, then we want to find our slope or the average rate of change because it's not a constant slope, so we call it average rate of change. Let's see, I need to go from 3 to 4, so I'm going to use these two. So we put our y's up on top. So my 307 minus my y1, which is 279, over my x2, which is 4, minus my x1, which is 3. 307 minus 279. (28) over 1, which equals 28 feet per second. And I think I'm going to stop there for today, and you guys can work on those problems. And then tomorrow we'll pick it up and finish the rest off. Sound like a plan?